Welcome friends. Topic of today's video is development of kidney. Two very important embryological structures that are important for the development of urogenital system is the first is the intermediate mesoderm and another one is the cloaca. So first let us understand where is the location of the intermediate mesoderm. Let us see in this first diagram. This is the cut section of the embryo. This is the uppermost ectoderm. This is the formation of the neural groove in the ectoderm. This is the underlying endoderm. This is the notochord, and between the ectoderm and the endoderm lies the intraembryonic mesoderm. Okay, now let us see what are the different parts of the intraembryonic mesoderm. The intraembryonic mesoderm is divided into three parts. First part is the paraaxial mesoderm, that is located on either side of the notochord and which is present in segments. So here lies the paraaxial mesoderm. On the two sides or the periphery lies the lateral plate mesoderm, which encloses a cavity. This cavity, which is known as intraembryonic coelom. So this is known as intraembryonic coelom. Okay. This layer of the lateral plate mesoderm is known as somatopleuric mesoderm, and this layer is known as the splaghnopleuric mesoderm. Okay. Between the lateral plate mesoderm and the paraaxial mesoderm, here lies the intermediate mesoderm. So here is the location of the intermediate mesoderm. So this one was the paraaxial mesoderm. This one was the intermediate mesoderm. This one was the lateral plate mesoderm. Which was divided into somatopleuric and splaghnopleuric mesoderm. In between the two parts of the lateral plate mesoderm, there was the intraembryonic coelom. Now, after the folding of this embryonic disc laterally and the formation of the peritoneal cavity in the intraembryonic coelom, the intermediate mesoderm forms a bulging in the posterior abdominal wall. These two bulgings. This is the mesentery and this is the plugging gut. This is the posterior abdominal wall, and these two are the bulgings of the intermediate mesoderm. This bulging, which extends from the cervical to the sacral region, from the cervical to sacral region of the developing fetus, is now known as nephrogenic chord. This is called as nephrogenic chord. This nephrogenic cords is just lateral to the attachment of the mesentery of the developing gut. This nephrogenic cord is covered by the lining of the peritoneal cavity. This is the peritoneal cavity. This lining epithelium is also known as coelomic epithelium. Now, very important four structures are formed in this nephrogenic cord. First is the excretory tubules, which is related with the development of the kidneys. So, here lies the formation of the excretory tubules in the nephrogenic cord. Now, lateral to the excretory tubules here occurs the formation of a duct which is closely related to this excretory tubule, which is known as nephric duct. So here forms the nephric duct. Which in further development will be called as mesonephric duct. Another duct is also formed which is just lateral to this nephric duct here, which is known as paramesonephric duct. Which is related with the development of female genital system. Here on the medial aspect of this nephrogenic cord, from the coelomic epithelium arises a mass that is known as the Gonadal Ridge, that will form the ovaries and the testes or the gonads in the humans. Let us see another diagram, this one. Here we can see this structure is known as the cloaca. We can see here also this one. This whole structure is known as cloaca. This is the cloacal membrane. Okay. This cloaca was divided by a urorectal septum into a rectum and a primitive urogenital sinus. This is the urogenital sinus. This primitive urogenital sinus was again divided into two parts by the attachment of this mesonephric duct. This mesonephric duct opens on the back side of the cloaca here and was dividing the cloaca into an upper part and a lower part. The upper part from here is known as the vesico-urethral canal, which will form the urinary bladder and the primitive urethra. And below structure, this one, this area, is known as definitive urogenital sinus. This definitive urogenital sinus will be again divided with further development into a pelvic part and a phallic part. Now let us look more closely into this diagram. As I have already told you, this was the cloaca. These are the two mesonephric duct, this structure, that were opening on the back side of the cloaca here, like this. This is the lateral view and this is the frontal view. These segmented things, these structures that you can see on either side of the mesonephric duct is the excretory tubules part, this structure. These are the excretory tubules which are related with the mesonephric duct. Okay, as I have already told you that this nephrogenic cord is extending from the cervical to the sacral region. Therefore, the excretory tubules will also be extending from the cervical to the sacral region. Now, these excretory tubules can be divided into three parts depending upon the region in which they lie. The excretory tubules present in the cervical region, this one, is known as the pronephros. The excretory tubules present in the thoracolumbar region is known as mesonephros. And the excretory tubules related in the sacral region is known as the metanephros. Also called as metanephric blastema. The development of kidney of the human embryo can only be appreciated if the evolutionary history of the organ is also kept in mind. The vertebrate kidney has passed through various stages of evolution. The most primitive of this is the pronephros, this structure, which is the functional kidney, in fishes and in some cyclostomes. So if you take an ultrasection of this pronephros, small excreted tubules are formed which drain into this duct, that is the nephric duct. So these tubules, small excreted tubules are formed which is draining into this nephric duct, which is related with the pronephros. These small tubules will act like a functional kidney in these fishes and cyclostomes. In human, these pronephric tubules which are present in the pronephros and this part of the nephric duct which is related with the pronephros completely disappears. The pronephros is succeeded by the mesonephros in the higher vertebrates, which is the functional kidney in most of the amniotes. Here also, the mesonephros is composed of small tubules which drain into this nephric duct. Now, this nephric duct, which is in relation with the mesonephros or the mesonephric tubules, is now called as mesonephric duct. Most of the mesonephric tubules, these tubules, disappear, but some of them remain, which participate in the formation of the ductal system of the testes. Now, the kidney of the amniotes, including human, is formed by the metanephros, this area, or the metanephric blastema. During the development of the human embryo, the evolutionary history of kidney repeats itself. This is the classic example of the saying that ontogeny repeats phylogeny. Ontogeny repeats phylogeny. Now, a small bird appears from the mesonephric duct just above its opening into the cloaca, which grows canally towards the metanephros or metanephric blastema and grows into it. This structure or bud is known as ureteric bud. So here also we can see that this is the pronephros, this is the mesonephros, and this is the metanephros. The ureteric bud grows here from the mesonephric duct towards the metanephros and grows canally, enter into the metanephros. Now let us see in another diagram what is the fate of this ureteric bud and the metanephros. Now let us draw the metanephros and the growing ureteric bud. This is the metanephros. This is the growing ureteric bud which is growing cranially into the metanephric blastema or the metanephros. The growing end of the ureteric bud becomes dilated to form that is known as ampulla. This ampulla or the growing end of the ureteric bud now starts dividing or branching. This was the metanephros. Here you can see the ampulla has got divided into two branches. Now there are two growing ends. These growing ends will again start branching like this, and there will be many generations of branching. First 3 to 5 generations of branching fuse to form the pelvis of the ureter. Next branches or the divisions will form the major calyx. And the further divisions will form the minor calyces and the connecting tubules. Now let us look what happens to the metanephros. The growing tip or the divisions or the branches of the uretic bud will again become enlarged to form ampulla. So if this is the ampulla, these are the divisions of the uretic bud, and the portion of the metanephros which is surrounding this tip of the growing tip of the uretic bud will get differentiated and will form the nephron. This differentiation of the metanephros is under the influence of the ampulla or the growing tip of this uretic bud. This will influence the metanephros to form the nephron. These loose tissue of the metanephric blastema or the metanephros will become solid or clump together to form clusters of cells. Now each solid clump is converted into a vesicle. So here, if this one was the growing tip of the uretic bud, a vesicle will be formed by the metanephric blastema. Now this vesicle will soon become pear-shaped and open into the uretic bud. So on later stages, this is the uretic bud. The vesicle will become pear-shaped and will open into the uretic bud. The vesicle will now become S-shaped This vesicle will become S-shaped. Now, the distal end of this S-shaped tubule is invaginated by a tub of capillaries like this to form the glomerulus, and the remaining part of the S-shaped tubules will form the proximal convoluted tubule, the loop of Henle, the distal convoluted tubules, so in this way the different parts of nephron is formed by this S-shaped tubules. Now the various anomalies of the kidney. A very important anomaly of the kidney is the congenital polycystic kidney. Congenital polycystic kidney. In this, many cysts are present in the kidney. These cysts are formed due to the failure of the fusion of the S-shaped tubule with the developing uretic bud. So, when failure of establishment of contact between the uretic bud and the S-shaped tubules occur, this S-shaped tubule will remain as a separate structure and the uretic bud will not fuse with it. But this S-shaped tubule will continue to produce urine and will become enlarged and dilated to form cyst-like structures. Okay? In this way, many cysts are formed. Therefore, it is known as polycystic kidney disease. And since it is present from birth, it is known as congenital polycystic kidney disease. Now the ascent of the kidney. Since the metanephros was present in the sacral region, the kidneys has to ascend up to the lumbar region. This is due to the differential growth of the abdominal wall, which causes the kidneys to extend towards the lumbar region. The metanephros was initially taking blood supply from the lateral sacral arteries. But with the ascent of the kidney, higher branches of the abdominal aorta will take over, that is the renal arteries in the lumbar region. Sometimes these lateral sacral branches remain and they are known as aberrant renal arteries. Sometimes the lower pole of the two kidneys, these two lower poles, get fused together to form a horseshoe-shaped kidney. Since it looks like a shoe of the horse, therefore it is known as horseshoe-shaped kidney. A horseshoe-shaped kidney does not ascend upwards than the level of the inferior mesenteric artery, because the inferior mesenteric artery will hinder, this is the inferior mesenteric artery from the abdominal aorta, this will hinder in its ascent of the kidney. Therefore, it doesn't go above the level of the origin of the inferior mesenteric artery. Thank you very much. This is the development of the kidney and anomalies related to the kidney. Thank you.